Okay, so important, okay, so here's your picture of a function, and it's the picture that goes with the difference quotient. Okay? And it also goes with a trapezoid. Okay? Now the question came up, what's that little green thing there again? What's the name of that? Everybody knows what it is. It's a fundamental triangle, and that's just a term I use. Okay? Now what I just said is that in order to understand the difference quotient, you have to understand the fundamental triangle. Okay? If you can use the difference quotient, you can plug numbers into the difference quotient till the cows come home. You can plug symbols into it. You can do anything, but you don't understand it unless you understand this triangle. Okay? So I'm going to say that this is necessary for understanding the difference quotient. You can use the difference quotient without understanding it up to a point. Well, I'm not going to extend it anymore, right enough on the board, okay. And I say necessary, I really don't know how everybody's brain is wired. I'm fairly confident that for the vast majority of people, it's necessary. Then I'll put probably necessary for understanding the difference quotient, because I don't know everything there is to know. Okay? And I'm sure there are people out there, maybe some of you, who can understand the difference quotient just fine. But when I say understand it, I mean understand it so that you can actually apply it to the real world in a way that meshes with what your gut tells you.
And what is represented by the difference quotient?
That's where we're going. Okay? So, I'm going to give you a situation. Familiar situation, depth versus clock time. Okay? My question is, then what does a difference quotient mean? Now, how do you answer what the difference quotient means?
Is that going to be your slope? The difference quotient?
The difference quotient is a slope. Okay? Because the difference quotient is, well, let's look at the fundamental triangle.
It's going to be...
So here's your fundamental triangle. What's the rise of your fundamental triangle for this picture?
Delta X.
No, but hold that answer. It's probably the answer to my next question.
That's the run.
What's the rise?
Delta.
Delta? Delta what?
Delta X.
No, delta X goes this way. The rise goes this way.
F of delta X.
No, that wouldn't be the rise. To get a rise, you got to have 2 points. You get f of x, or f of delta x, or f of anything. That's just.
Well, why I'm saying it is why I'm saying it's delta X specifically is because your y value for x is f of x. So so if you go up to that same y value for the x plus delta x, you're just gonna get f of x. But, to get the y value for delta, for, f of x plus delta x is gonna, to get the y value for x plus delta x, you're gonna have to add delta x.
No, you cannot, everything you said there is correct until the last word.
Add f of delta x.
No, f of delta x isn't important at all. You know, delta x is this far, so f of delta x is what you get from this point. It has nothing to do with the rise. Yes, Morgan.
You just subtract them.
Again?
You just subtract f of x plus delta x plus delta
Yeah. How do you get the rise of a trapezoid? You subtract this from this, right? I mean, if I gave you, if this is 4 and this is 6, what's the rise?
6 minus 4.
I'm sorry?
6 minus
Did you say 6 minus 4? Yeah, which is 2, right? It's pretty obvious. If this is 4 and this is 6, then the rise is 2, isn't it? And if not, you know, do more trapezoidal graphs, okay? Analyze more trapezoids. Because that's real fundamental. I kind of assume everybody knows that if I give you two numbers. The thing that's throwing people is that we're doing this with symbols, and that's not something you're overly used to doing, okay? So think of what you would do if you had two numbers here. Just pick two numbers. Two numbers that look about right. Maybe 7 and 10. What's the rise?
3.
3. How'd you get that?
10 minus 3.
You subtracted
10 minus
this from this. Now, you're going to do the same thing for any trapezoid, and if the trapezoid has this, f of x and f of x plus delta x, you're going to subtract f of x from f of x plus delta x. You're going to subtract the earlier value from the later value, right? For reasons that we understand in terms of how you get the change in temperature between two temperatures, right? Subtract the temperature you get from the temperature you started with. Okay. So, what's the rise of this triangle? It's f of x plus delta x minus f of x, right?
Would that or would that not be equal to f of delta x?
Not at all. What if delta x is very tiny? Where's f of delta x? Well, you go over here to coordinate delta x and you get this, and the value of the function here has nothing to do with the slope, right? And I understand why you're asking that.
Okay.
F is not a linear function. So function notation doesn't distribute over the plus. Now if you think f of x plus delta x equals f of x plus f of delta x, then you would say what you're saying, but it's not true. If x is a squaring function, the square of x plus delta x is not the square of x plus the square of delta x, okay? So, and it's real easy. And this is what I mean by be careful about doing mathematics by superstition. Okay, and I use the word superstition kind of facetiously. It's you know, a little higher level than superstition. But if you think that this is f of x plus f of delta x, there's no rule in the world that says that's so, and there's an easy counterexample. If f of x is x squared, it can't be. Okay? If f of x is a linear function, well, then it's true. And it's true if and only if f is a linear function. In other words, if the graph is a straight line. Okay? Actually, it has to be a straight line through the origin. No, just any straight line. Yeah, maybe a straight line. Yep. Have to write it out. Okay? Certainly true for a straight line through the origin. Okay, but anyhow, so don't confuse that with f of delta x. Okay? So I'll make a little note. Function notation I'm going to go to really formal mathematical expressions and say it don't know how distribute. Okay? For emphasis, I'm going to use bad grammar, but I'm going to pretend that's how you really say it in sophisticated mathematics. Okay. So you want to think about what that means. That's very important. Okay? Now, the other thing is, what's the run?
Delta X.
Yeah. And that is this minus this, which turns out just to be the delta x. We understand that perfectly. Okay? Okay, well, but now in terms of meanings, if y is depth, let's say in feet, and x is clock time, in years, what's the meaning of the difference quotient?
Feet per year.
Yeah, but why? Well, let's think about, you got to go back to what's the meaning of the rise, right? Yeah.
The meaning of the, sorry, it's going to be feet per year because the y value, as it says, is depth in feet. So you go up a certain amount of feet as a certain amount of years go by.
Yeah. And intuitively, that's absolutely correct, and it's really very much correct. We want to make sure we get every step of the reasoning, but you clearly understand every step of the reasoning. But let's be sure we're real explicit about it, okay? So, okay, so what I'm saying is, f of x plus delta x is the depth from the times x plus delta x. F of x is the depth from the time is x. So f of x plus delta x minus f of x is, and I left out an essential word, I can't believe I did that, is the change in depth when the time changes from x to x plus delta x, right? In other words, the rise of the fundamental triangle is change in depth. Okay? Delta x is the change in clock time, right? and it's the run of the fundamental triangle. Okay? The slope, which is rise over run, is change in depth over change in clock time. And what's another way of saying the change in depth divided by the change in clock time?
Change of y over change of x.
It's a change in y over
Delta
change in
y
x.
Over delta.
It's what?
Delta y over delta.
Yeah. How would we describe it in words rather than mathematical symbols? Everything you say is correct. All those connections are important, so it's good that you see that. Okay, but you know, intuitively, what does this mean?
I don't have enough word to write you on.
What if the change in depth over the change in clock time is greater for one interval than for another? What's that tell you is going on? What's happening in the real world to the depth of the water? What?
It's either increasing or decreasing.
Increasing
Or decreasing.
or decreasing. Well, it does tell you whether it's increasing or decreasing, because if this ratio is positive, that means your water level is going up. Because the only way it can be positive if delta x is positive is if your delta y is positive, right? Which means that y is going up. Your depth is going up, right? So that's good, and that's important to understand. But, you know, words that we've used, okay? And the words that we've used, let's see. How fast the depth is changing on the average for this interval. And whether increasing or decreasing. Does that make sense? And this is what we call the average rate of change of depth with respect to clock time. This is how we analyze the meaning of the difference quotient. I need to step out for just a minute.